Welcome to this video, which deals with mathematical modeling, and this is without the slope involved in it. If you see the phrase rate of or rate of change, then you're involved with slope. In this particular word problem, I have something very similar to what I had in class. Kelly has two part-time jobs on campus. Her job in the X-ray lab pays $15 per hour, and her job at the yogurt shop pays $10 per hour. She earns $300 in a given week. We could basically figure out many ways where she could earn a total of $300 depending on how many hours she worked in the yogurt shop and how many she worked in the X-ray lab. You could have multiple answers. This can best be represented mathematically by looking at each phrase separately. We look at the X-ray lab situation where she's paid $15 an hour, and I can represent that by 15 and some variable. I'll use the letter X for X-ray. So X represents the number of hours here. So if she worked 1 hour, she earns $15. If she works 4 hours, it's 4 times 15. I'll give that to you visually, and $60. If she worked 6 hours, it would be 6 times 15, or $90. So you calculate it that way. If we look at the other part of the statement, where she has a job at the yogurt shop at $10 an hour, you would do something very similar, and you would write 10 and some other letter. I'll use Y for yogurt shop. And that again represents, in this case, the number of hours that she worked. So if Y happened to be 1, she made $10. If Y happened to be 4, she earned $40, etc. But it said that when we add these two values together with a plus, that the total for the week is $300. Now there are a number of ways that we could represent this on a graph. Pardon me, I'm having to adjust my headphones. We could do this by doing a line graph, because this is an x and a y equation with no exponents. This is going to graph as a linear function or a line. The word linear contains the word line. You can put values in there any way you want to. It depends on what method you want to use. One method, and again I'll write this down as method 1. You take the approach that you like best. Method 1, you could just plug in some values like you have right here and try to solve the pair of numbers. For example, and I'm going to erase this temporarily, if you want to just pick an arbitrary number for x, let's suppose that for x you pick the value 2. I'll put the 2 right there. That's not 152, that's not 17, that's multiplication. So 15 times 2 would be 30, plus 10y equals 300. And what you would do is solve that for y. And you could find the answer that way. You may end up possibly with some fractions when you go in this direction. That's something that you have to decide individually. You could plug a number just as well for y. If you wanted to put the value of y as 3 and you wanted to have 15x plus 30 equals 300 and solve it for y, you could go that approach. Method 2, which I'm about to show you, is probably the better way to do it algebraically. That's what most instructors would probably prefer. Method 2, what I would do is do the standard protocol and solve for y. The way you solve this equation for y is you first of all isolate the y term so that it's in on one side by itself, and then solve for y. I'll give you both these steps. To isolate the y term by itself, I want to take this guy and move it to the other side. Now I can't actually get rid of it on both sides, because if I subtract 15x from both sides, if I do it to one side, I've got to do it for the other side, or otherwise I don't have an equation. Alright, and when I do that, and I'm going to keep the equal mark straight right here, 15x minus 15x, of course, is going to be 0. That's going to zap out, and I'm left with 10y, which I'll move down here. So I've got 10y. And my personal suggestion when you're doing this particular kind of equation is to put the x term first. So instead of putting 300 minus 15x, I would put minus 15x plus 300. I'll see if I can make this just a little bit better. And then all I have to do is solve the equation for y. Now again, the x and the y will not disappear on their own. If they do, you did it incorrectly. So I've isolated the y term. Now I'm going to solve it for y. I'll do that by dividing both sides by a number that will get rid of everything except the y. So in this case, the logical division would be to divide by 10. Had there been a negative right there, I would have put a negative also. So if that had said negative 10y, I would divide by negative 10. Of course, that's not the case. I'll erase that very quickly. Now, even though you could put a big underscore and put 10 right there, I'm going to suggest that you do this unlike what the book says. I'm going to suggest that you do it individually and put a 10 under each part. Don't be afraid of fractions if that happens. So what this will give me is y equals negative 15 over 10. I'm going to reduce that, which you did in Math 60. I'm going to reduce that by dividing by 5, so 15 tenths would be the same as 3 halves. For those who are absolutely lost, I'm basically taking 15 over 10 right here, and I'm just dividing top and bottom by 5 to reduce the fraction. That's going to be negative 3 over 2. That's just basic arithmetic there. And 10 to 300 will be 30. So I've solved this same equation for y. This is just another form of the original mathematical model. Now in your exercises in the book, you don't have to do anything except write this equation. You don't have to solve it for y. But I'm doing that as a little extra treat here in case you run into this situation in another problem. Now what you can do here, this makes substituting sometimes a lot easier than method 1 I did earlier. For example, and I know even though this is a weirder looking equation, this still gives me the $300 deal right here, and I'll prove this to you. For example, I can set up a table of values for x and y, and one of the easiest ones to put in for x would be 0. So if I put 0 right there, that's going to make y become 0 plus 30, and y will equal 30 right here. So I have a pair of numbers 0, 30 right there. I could put in the number 2. I'll put in negative 2 in fact. I'm going to just pick negative 2 for x this time. I can pick negative 2 because I felt like it. That's the only reason. I'll put negative 2 in the place of x. So if I put negative 2 right there, that's multiplication. So negative 3 halves times 2, negative 3 halves times negative 2, the 2's will strike out, and those two negatives will end up being a positive 3 plus 30, and y becomes 33. What I've done, because everything, if I'm substituting for x, I don't have anything to worry about in solving for y, I just do the calculations on the right side of the equation. Now I would normally not do that in this situation because you can't work negative 2 hours, but just for the sake of applying the point, I could do that. Just letting you know that you can substitute any value you want to under normal circumstances. In this particular case, I'm not going to do negative because since I'm dealing with a person's hours, you can't work negative 2 hours. I'll just put plain old 2 right here for right now. X is 2. If I put 2 right there, I end up with negative 3 halves times 2 plus 30, or negative 3 when I work it out plus 30, and that will give me the number 27. So if x is 2, y is 27. I'll give you another example, a third example right here, just to give you something different. And again, I'll erase this so it'll be a little bit easier to see on the video. Bear with me while I do this little magic. Thank you for your patience in my getting used to this inking procedure. Let's say that I put in 10 for x. If I put a 10 right there, that's going to be negative 3 halves times 10. And you can write that as negative 30 over 2, which is negative 15. I'm going fast because this is basic arithmetic. Then I bring down this plus 30 right here, and y becomes positive 15. Now what's the significance of these numbers? The significance of these numbers is that when I look at the original equation that I had, the original mathematical model, these pairs of numbers will work themselves out. And here's the proof. When x is 0, that means I did not work at the x-ray store. And when y is 30, I worked 30 hours at the yogurt place. That's 0 plus 30, $300. Alright, take the second situation. Let's suppose I work for 2 hours at the x-ray place. X is 2. This is what I solved earlier just a moment ago. X is 2, y is 27. I end up with 2 times 15 is 30. 10 times 27 is 270. That's another way I could earn $300 for the week. So these pairs of numbers are all possibilities of how many hours that she could have worked at the X-ray lab and at the yogurt shop. If I wanted to actually place this in the form of a graph, I could do that by just plotting these numbers. And again, I'm doing this in a very, very sketchy way just to let you know. Let's say that this is in increments of 10. And let's say 0, 30 is right here. Let's say that 227, and this is not a very good graph because I'm having to do this very quickly for a video. Let's say that 227, I did this, let's say over 2 and up 27. Whoops, get this right. And I got to get this right. I got to back up. I goofed on this. I apologize. I messed up. Let's try this again, guys. Draw this line one more time. And I don't re-record videos, folks, so I don't have time. I'll go 0 and up 30. Here we go. This is 0, 30 right here. Don't go anywhere on the X. Go up 30 on the Y. 227. Go over 2, up 27. Go over 10 and up 20, and you get an idea. This is very approximate of how the graph would look. Incidentally, notice that that line leans to the left, so it's a negative slope because it leans to the left. So it's a negative slope. In fact, the slope of that line is actually given in the equation up here where I solved way back here for y. This guy right here, and I'm going to erase all the stuff around it so that it's kind of by itself so you can see it. When this equation was solved for y, right here, the actual slope of the line is the negative 3/2 that I had earlier. This 30 right here is something called the y-intercept. That's the value of y when x is 0. Now again, I'm getting all this crazy erasing stuff because I'm in a corner with this little inking problem. Hopefully this at least gives you a good idea of what the mathematical model is like. Now in another video I will show you a mathematical model that deals with rate of change. Notice there's no rate of change in this example. Get some tutoring or ask me as the instructor additional questions if you have difficulties still.